This is 5.3 Laws of Logarithms. There are 3 laws of logarithms. As you can see, I have written down here. The first law of logarithms is to have log base a of a times b is equal to 2 separate logarithm functions being added together as log base a of a plus log base a of b. So let's look at our examples here. Here we are expanding for numbers 1 and 2, and for number 3, I will be evaluating. So for expanding, all I'm doing is rewriting this as a note up here as 2 logarithms being added together. Since I have 2 terms that are being added here, or multiplied here, the 4 times dx, I will have 2 separate logarithms. So this becomes log base 2 of 4 plus log base 2 of x. And that's all I do to expand. With log base 4 of x times x plus 3, again, I only have 2 terms. So this would become log base 4 of x. Let me rewrite that. Log base 4 of x plus log base 4 of x plus 3. I cannot split the x plus 3 up at all. Now, if I had 3 terms or 4, I would just have to have 3 or 4 separate logarithmic expressions that were being added together. Okay, let's look at the evaluating. So I have log base 3 of 2 plus log base 3 of 4.5. So here I'm starting with 2 logarithmic expressions added together, and I'm going to put this into one logarithmic expression as log base 3 of 2 times 4.5, which is log base 3 of 9. And now I use the definition of logarithms to evaluate this. So if I think about the exponential format of this logarithm, if I set this equal to y, this would be 3 to the y is equal to 9. And if I think about what exponent will give me 9, I will find out, or think about, that y equals 2. So this answer to this logarithmic expression is 2. Okay? Now let's look at the second law. The second law is to take log base a of a divided by b and to split that up into 2 expressions that are being subtracted. Log base a of a minus log base a of b. Again, we will expand and we will evaluate. So to expand, we have log of x divided by 5, and I will split that up to be log of x minus log of 5. Now, you may notice here I did not have a base number, but the base number is 10. Let's look at the second example. I have log base 3 of 4 divided by 7. So I will expand that to be log base 3 of 4 minus log base 3 of 7. To evaluate, I have log of 5,000 minus log of 5. So I will combine those to one expression where I have log of 5,000 divided by 5. And 5,000 divided by 5 is 1,000. And because this is base 10, I will again think of what exponent will give me 1,000. And if I think about 10 squared is 100, 10 to the third is 1,000. So the answer here is 3. And on to the third law. The third law is to take log base a of a to the c with an exponent and move that exponent so that it is out in front, being multiplied by log base a of a. So let's look at the examples here. This first example, log base 6 of x squared. So I'm going to take that exponent, I'm going to write it out front, and then log base 6 of x. And that's my answer. And that is rewritten to be the same meaning. Now with log base, or I'm sorry, log of the square root of x, if I think about what the square root means, that means I have an exponent of 1/2. And now that I have an exponent, I can move that out to the front, and I get 1/2 times the log of x. And let's look at evaluating. I have log base 2 of the cube root of 4. Well, the cube root is the exponent of 1/3. So that's going to be 4 to the 1/3. So now we're going to move that to the front. We get 1/3 times log base 2 of 4. And when I look at just the log base 2 of 4, that is thinking what exponent on 2 will give me 4. Okay, well, I need an exponent of 2. So this is 1/3 times 2, which is 2/3. Okay, those are the 3 laws of logarithms. Now let's look at doing some examples where we put this all together. Okay, so if I have log base 5 of x to the third times y to the sixth, and I need to expand this. I have multiplication and I have exponents. So the first thing I want to do is to split this one logarithmic expression into 2. So split the expression into separate expressions. Okay, so that means I'm going to have log base 5 of x to the third plus log base 5 of y to the sixth. Now I have these exponents, and I'm going to move those out to the front. So I'm going to have 3 times the log base 5 of x plus 6 log base 5 of y. And that's my final expansion. Okay, let's look at another example. If I have the natural log of a times b divided by the cube root of c. I'm going to treat natural log the same way as I do these other logarithmic expressions, because really they are truly the same thing. It's just that natural log is log base e. So it's not any different. So again, I'm going to split this up into separate expressions. So I have multiplication and I have division. So I have ln natural log of a, and I'm multiplying that times b, so plus natural log of b, and now I'm dividing by the cube root of c, so I'm going to have minus the natural log of the cube root of c. And really there's nothing I can do with natural log of a or natural log of b, but with the natural log of the cube root of c, I can convert the radical into an exponent, and then because I have an exponent, I can move that out to the front. I'm only going to move it out into the front of that expression, now not out in front of all of them. So finally, I will get natural log of a plus natural log of b minus 1/3 natural log of c. Okay? And the third example here, I have log of a squared over b to the fourth times the square root of c. All right, so here again I have division and I have a multiplication. So I have three expressions, three terms, whatever you want to call these, that are within this logarithmic expression. So I'm going to split this up into three logarithmic expressions. And because I am dividing by two terms here, I'm going to put those in parentheses. So I have log of a squared minus log of b to the fourth, and these two are being added or multiplied times each other, so these will be added inside the parentheses here, and it will be log of the square root of c. And just like regular algebra, I have this minus, I'm subtracting an expression, two values being added together. So if I kind of distribute that subtraction, I will get log of a squared minus log of b to the fourth minus log, and I'm going to go ahead and change that to be c to the 1/2. Okay, so what I did was I distributed the subtraction, so I'm really subtracting both of those. And now I have all exponents here, and I'm going to move them out to the front of each expression. So 2 log of a minus 4 log of b minus 1/2 log of c. And now let's look at one more example. If I have the natural log of a to the third times the cube root of b over c squared. Since this radical is affecting both of these, there's a couple ways I can go about this. I could go to, I could go ahead and distribute that radical and split that up to be the cube root of b over the cube root of c squared, and then just go ahead and go about my way. Or I could have written this as a parenthesis to the 1/3, like this, natural log of a to the third times b over c squared to the 1/3. third. I could split this up into two expressions, move that exponent out front, but I think this gets a little bit more confusing. So I'm not going to show you that way. So I like to go ahead and split this up because eventually you're going to split this up anyway, so it may as well be done at the beginning. So now I have three expressions. I have natural log of a cubed. That's multiplication, so this is going to change to addition. And I have two things that are grouped here, so I'm going to put them in parentheses. So the natural log of the cube root of b minus the natural log of the cube root, well, I'm going to do that, cube root of c squared. Okay? Now, because I'm adding out here in the front, it's not going to change anything on the inside of the parentheses. And so when I rewrite this, nothing will change, and I can get rid of the parentheses. So natural log of b to the 1/3 minus natural log of c squared to the 1/3. Well, that's going to just be 2/3. Because we already have an exponent here. It's not going to be 1/3, so it's 2/3. And now I'm going to take those exponents and write them out to the front. So 3 natural log of a plus 1/3 natural log of b minus 2/3 natural log of c. Okay? Now let's look at combining some expressions. If I have 2 log base 3 of a plus 1/3 log base 3 of b minus 4 log base 3 of c. To be able to combine these, I do have to have the same base value on all of your logarithmic expressions. Okay? When I look at this, I need to realize that I have numbers out in the front. And every time when I worked with the expanding, I always ended up putting these numbers out to the front as my last step. So what I'm going to do is I'm going to take care of these first when we are doing the combining. And these are the coefficients, if you remember, those usually came from an exponent. So we are going to put coefficients as exponents. And that's going to be our first step. So we get log base 3 of a squared plus log base 3 of b to the 1/3 minus log base 3 of c to the 4th. And the b to the 1/3 is the same thing as the cube root of b. So I'm going to have that, because I'm running out of room here. I'm going to write that in there. Pardon me here. Okay, now I'm going to start to combine these. Because I have addition here, these two are being multiplied, and this subtraction means I'm dividing by the C4. So I have log base 3 I'm going to have a division here, but a squared times the cube root of b are both on the top of the fraction. And because of the minus, I have the division of c4, c to the fourth. And that is our expression combined, our three expressions combined into one. Let's look at another example here. So we have natural log of x plus y plus the natural log of x minus y minus 2 times the natural log of 2. Again, I have two expressions. Oh, I've got a coefficient here, so I want to take care of that first. So I'm going to move that to the back here. And let me get my red here. I'm going to cross that out, and I'm going to write it as an exponent on the 2. And now I have addition here, so I'm going to multiply these, and then I'm divide by the 2 squared, which is 4. So 2 squared equals 4. And I'm going to have the natural log of x plus y times x minus y over 4. And I'm going to go ahead and multiply these out. So when I do x plus y times x minus y, if you know the difference of two squares really well, you will already know the answer to this. But if not, you can go ahead and distribute the terms. So x times x is x squared. X times the negative y is going to be minus xy. Y times x is plus yx or xy. And y times negative y is minus y squared. These two middle terms are opposites of each other, so they will cancel, and I will get x squared minus y squared. Okay? So, like I said, if you know difference of two squares, you would know that answer right away. And we end up with natural log of x squared minus y squared over 4. So, I didn't show any examples when we were doing the expanding where we had factorable expressions. But you need to be aware that that is a possibility. Just like here, we were able to multiply that in and come up with something um, more condensed because we could actually multiply x plus y times x minus y. So if I had to work this backwards and expand my natural log of x squared minus y squared over 4, I would have to know that x squared minus y squared is factorable. And I would factor that before I could expand. Okay, so let's look at a third example. And I have 3 log of x minus 1/4 log of x minus 2 plus 2 log of x squared plus 1. Okay, so I'm going to take care of the exponents first. So log of x to the third minus log of x minus 2 to the 1/4. Okay, I'm just moving all these exponents or these coefficients up to the exponential area. This is a 4 here. I'm going to rewrite that 4. Okay, plus log of x squared plus 1 squared. Now, in these situations where you have the expressions with an exponent, you do not need to distribute or multiply this out. Obviously, you can't distribute here. You'd have to do x squared plus 1 times x squared plus 1. But that isn't necessary unless it were able to be simplified out with something else and combined. But we have the fourth root here, which is going to make a radical. Over here will just give us um, separate terms, and we cannot combine those with anything, so it's not going to help us. All right, the fourth root of x, I'm sorry, x minus 2 to the 1/4 is going to be the fourth root of x minus 2. So I'm going to go ahead and write that out, save myself a little bit of space here. And now I'm subtracting here, which means I will have log of x to the third over the fourth root of x minus 2. Now we're adding log of x squared plus 1 squared, which means we're going to multiply that. Well, if I'm going to be multiplying a fraction times another thing here, um, you're multiplying the numerators anyway, so we could just go ahead and write that on the top here like that. So let's see here. Okay, this is, there we go. X cubed times the quantity of x squared plus 1 squared all over the fourth root of x minus 2. So the log of that. Okay, and that's our final answer for that. And one last thing. We have the change of base formula, which is log base b of x. And we can evaluate that by taking log of x divided by log of b. Now the log button is on your calculator, but generally we don't have the base value. So unless you've been taught another way to do that on your calculator, we can't do this unless we split this up. So if you kind of think about how you can see the x is at a higher level than the base of b, so we want the x on the top and the b on the bottom. Okay, so here we have the 5 is the large value, so it's log of 5 over log of 8, and you can do that on your calculator. Log of 5 divided by log of 8, and you will get a value approximately equal to 0.774. With log base 9 of 20, we will have log of 20 is the large number over the base, which will go to the bottom, log of 9, and you do log of 20 divided by log of 9, and you will get a number approximately equal to 1.36. And I did the same problem here just to show you that if I did the natural log of 20 over the natural log of 9, I would get the same exact answer. So it doesn't matter if I choose log of 20 over log of 9 or natural log of 20 over natural log of 9. No matter what, I will get 1.36. Okay, so depending on your preference or depending on the situation, what's going on and how you see it, it's doing the same thing. Okay, and that was a long video of 29 minutes, but we're done.